So for section 1.8, we're going to talk about dividing segments proportionally, or that's also called partitioning. This is an extremely important section. There is a question with partitioning on the Regents on every single Regents exam, so it's extremely important. Okay, so to divide a segment proportionally, you must divide the total number of parts it's divided into. So in other words, if you have a ratio of 2 to 3, that's really 5 parts. So again, if you look at line segment AB, and again, two-thirds ratio, there's 1, 2, 3, 4, 5 sections total. So it's really breaking that into 5 separate parts. So there is a formula that you can use for partitioning a segment into the ratio of A to B, and that's this mess of a formula here. Even though it looks messy and it seems like a very complex formula, it's really not. Again, to get our x coordinate, what we're going to do is take x1 and we're going to add a over a plus b. And again, the a and the b are going to come from whatever your ratio is, times x2 minus x1. And then for our y's, we'll do y1 plus that same exact fraction of a over a plus b, again coming from the ratio, times y2 minus y1. Now, unlike examples that we've done before with distance, it didn't matter which one that you called x1, y1, which one you called x2, y2. In this case, it does. When you are partitioning, the first set of ordered pairs that you're given, that's the one that you must call x1, y1. Okay, so in my case, since I always call the first ordered pair x1, y1 anyway, it works out well. Okay, so for our first example for our partitioning here, we want to find the point on AB that divides it into the ratio of 1 to 2. So again, just gave you a picture over on the right-hand side so that you can see, and also you have your endpoints there. And again, ratio of 1 to 3 means that we're going to divide that line into 3 equal sections. So the 1 plus the 2 means that we have that line segment being broken into 3 parts. So our coordinates of A are going to be 3, 4, and our coordinates of B are 6 and 10. So again, I know you can see that over on that right-hand side, but I just wrote it over here so that I can label that x1, y1, and x2, y2. So again, A has to be the x1, y1, and B has to be the x2, y2. Hey, I'm not going to try to rewrite that formula that's up there. Again, when you're doing this on your own, the more times that you rewrite that formula, the more likely that you are to remember it. Okay, so the first thing that I have inside our set of parentheses is x1. So in our case, x1 is 3. To that, I'm going to add a over a plus b. So again, when I'm looking at my ratio of 1 to 2, let me just write it up here so I can see it a little bit better. That's a to b, which means that your a is going to be 1 and your b is going to be 2. So on the top, a is 1. And on the bottom, we're adding a plus b. So 1 plus 2 is that 3 that we got there. And now I need to multiply that times x2, which is 6, minus x1, which is 3. And that's going to give us the new x coordinate. And then we're going to do the same thing on the y side. So on the y side, again, the first thing I need from this formula is the y1. And y1 in this case is 4. And again, to that, we're going to add a over a plus b, which is the same thing that was over here. So in this particular case, that's going to be our 1/3. And this time we're doing times y2 minus y1. So y2 is 10 and y1 is 4. So again, just make sure that you follow order of operations here. So I'm going to have 3 plus 1/3. 6 minus 3 is 3. I'll continue on the other side as well and do the subtraction on that side. 10 minus 4 is 6. It's going to be really helpful to have your calculator out at this point. Please make sure that you are playing along with me. And if for some reason you're not getting the same answer, please reach out and ask. Just because I think I got it right doesn't necessarily mean that's always the case, because sometimes I make a typo just like you do. But again, you should be getting the same exact answers that I do. So if you're not, please definitely reach out, because how you plug this into the calculator is very important. Okay, so inside your calculator right now, the next thing that you would do is the multiplication, or 1/3 times 3. So inside your calculator for 1/3 times 3, I'm just going to come over to the top over here in purple for 1 second. You would type in your calculator 1 divided by 3 inside a set of parentheses times 3 and then hit enter. Okay, so when you do that, it should give you an answer of 1. So I'm going to have 3 plus 1 on the left. And on the right, I'm going to put that into the calculator the same exact way. 1 divided by 3 inside a set of parentheses times 6. And when you do that, this time you're going to get an answer of 2. And again, 3 plus 1 is 4, and 4 plus 2 is 6. So the point that will divide that into a 1 to 2 ratio is going to be the 0.46. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So that point right there. So you can kind of see how this is going to be the one part, and then there's 2 parts up there. Okay, so for number 2, I have the points -4, 5, and 12, 13, and we want to find the coordinates of D that partitions AB into the ratio of 2 to 3. So again, since you can't see that formula anymore, I will take a second and I will rewrite it. It's x1 plus A over A plus B times x2 minus x1. And then for our y's, we're going to have y1 plus A over A plus B times y2 minus y1. Okay. And again, it absolutely does matter in this case which one you call x1, y1 and which one you call x2, y2. Our first ordered pair has to be the x1, y1, and our second one has to be the x2, y2. Okay, and now we'll go ahead and plug it in. So for x1, I have -4. Again, A and B are coming from that ratio of 2 to 3. A is going to be your first one. B is going to be your second one. So A on the top is going to be 2, and on the bottom, I'm going to add those two numbers together. 2 plus 3 is 5. x2 is 12 minus x1 is a -4. So you have 12 minus -4 inside those parentheses. On the right for y1, we have 5 plus that same 2/5 times y2, which is 13, minus y1, which is 5. Okay, again, simplifying what's inside the parentheses first. We're going to keep change, or add the opposite, however you want to look at it. So I'm going to have 2/5. 12 plus 4 is 16. And on the other side, when I do the subtraction there, 13 minus 5 should give me an answer of 8. Again, calculator is going to come in handy again here. When you do 2/5 times 16 inside your calculator, you should get an answer of 6.4. So you're going to have -4 plus 6.4. And then on the other side, when you do 2/5 times 8, and you hit enter in the calculator, it should come out to 3.2. So on that side, you're going to have 5 plus 3.2. Negative, again, use your calculator no matter how easy you think this addition is, because you don't want to make a simple mistake on adding or subtracting, which is obviously so easy to do. So -4 plus 6.4 will give you an answer of a positive 2.4. And on the other side, 5 plus 3.2 will give you an answer of 8.2. So the point that would divide that line segment in a ratio of 2 to 3 would be 2.4 and 8.2. Okay, 2 more examples here. Okay, this time we want to find the point on the directed segment from -2, 0 and 5, 8 that divides it in the ratio of 1 to 3. Again, directed segment just means, again, that the order matters. So you're going from and to, so the from has to come first. It's just a different way of saying that this has to be x1, y1, and that has to be x2, y2. So one more time, here we go with that partition formula. x1 plus A over A plus B times x2 minus x1. For the y's, it's going to be y1 plus A over A plus B times y2 minus y1. So x1 is -2. A and B, again, 1 is A, 3 is B. So A is going to be 1, and then on the bottom, A plus B, or 1 plus 3 will give you 4. So I'm going to have 1/4. X2 is 5, a minus sign from the formula, and X1 is a -2. So 5 minus -2. Y1 is 0. Again, that A over B is going to be 1/4, and Y2 is 8 minus Y1, which again is 0. Again, over here, we'll do keep, change. So we're going to have -2 plus 1/4. 5 plus 2 is 7. And on the other side, 0 plus anything is just going to be 0, so we can ignore that 0. So I'm going to have 1/4, and 8 minus 0 is just going to be 8. So again, in the calculator, if I do 1/4 times 7, I should get an answer of 1.75. So I'm going to have -2 plus 1.75. And on the right, when I do 1/4 times 8, that comes out nice and neat. That'll give you an answer of 2. So now we just have to add together on the left-hand side, the -2 plus 1.75 will be -0.25. And again, I'll just bring down that 2. So the point that would divide that segment into a ratio of 1 to 3 would be -0.25, 2. And our last one for today. We want to find the coordinates of P that is 3/4 of the way along a directed line segment from 6, -5 to -3, 4. So again, if it's 3 to 4, again, that's just a different way of writing your ratio. A ratio can always be written in fraction form. So again, this is just another way that they're kind of writing that for you. Okay, so again, we have X1 plus A over A plus B times X2 minus X1. Y1 plus A over A plus B times Y2 minus Y1. Okay, again, first ordered pair that you see has to be X1, Y1. Second ordered pair has to be X2, Y2. Okay, so X1 is 6 plus A, again, is coming from over here. Again, the one on the left is A, the one on the right is B. So A in this case is 3. And A plus B, 3 plus 4 is 7. X2 is -3, a minus sign from the formula, and X1 is 6. And on the right, Y1 is -5, plus that A over A plus B, which we already found is 3 over 7. And Y2 is 4 minus Y1, which is -5. Okay, so again, doing what's inside our parentheses, -3 minus 6 is going to give me an answer of -9. And on the right, I'm going to do keep, change. So 3 over 7, 4 plus 5, sorry, this keeps jumping, is 9. Okay, and now again, inside of your calculator, you can end up multiplying 3 divided by 7 times -9 and hit enter. It is going to come out as a very messy decimal. I'm going to do it right now. 3 divided by 7 times -9. It comes out to something like -3.8571, blah, blah, blah. It's messy. So inside the calculator, I'm going to go ahead and take that messy decimal, and at the same time, I'm going to add 6 to it. And it still comes out to a really messy decimal of 2.14 something. I'll write that over here. 2.14285. There's other numbers after that. But you don't want to leave that messy decimal. If something ever comes out as that messy decimal, you want to change that back into fraction form. So with that messy decimal still inside your calculator, all you have to do is hit the math key, which is on the left-hand side underneath your alpha. It's in the left-hand, most left-hand column underneath your alpha key. There's the word math. Just hit math. Option number 1, we're going to turn that into a fraction. All you have to do is hit enter twice and it'll spit out a fraction back at you, and that fraction is going to be 15 over 7. We'll do the same thing on that right hand side. We're going to do 3 divided by 7 inside our set of parentheses. This time we're multiplying by a +9. Gives you a very messy decimal of 3.857 something something. We'll add our -5 to that and hit enter again. So when you do that, something like -1.1428, again, there's more decimals after that. And we're going to do the same thing. Hit math, option number 1. So we're just going to hit enter twice, and it's going to spit back out a fraction at you of -8/7. So decimals are fine. You saw decimals up in earlier problems, but they came out nice and neat. 0.25, 0.5. You could even leave them as fractions if you want to. You can always leave them as a fraction. But when you get really messy decimals, you don't want to leave it like that. You want to put it back into fraction form, and you can always use your calculator to do that.